Hello, and welcome to MSA Prep for 8th grade science. Thank you for tuning in. I'm Scott Hange. I work at the Howard B. Owen Science Center, and today we're going to be focusing on one of the standards of science. That standard is Standard 5, Physics. Let's take a look at what that actually says. Students will use scientific skills and processes to explain the interactions of matter and energy and the energy transformations that occur. Well, in today's little video, we're going to talk about electromagnetism. And what I prefer to do is to show you the questions first, do a demonstration, and then we'll go back to the questions. So let's take a look at question number 1. An electromagnet is shown below. You can see there's a battery shown, there's a positive end, that's the end with a little bump on it, and the negative end of the battery. There's a wire, it's wrapped around in what we call a coil, and then you have a nail, and they say it's a steel nail. The question we have to answer is as follows. What change would decrease the strength of the electromagnet? A, using an iron nail. B, using an additional battery. C, using more wire coils around the nail. Or D, using fewer wire coils around the nail. And again, when questions like this are written, you need to look at clues. And if we look at the question again, just very briefly, notice the word decrease is underlined. That's a clue. Decrease means to make weaker or lessen. Let's take a look at the second question. The second question states, a doorbell contains a simple electromagnet. Which change would most likely increase the strength of an electromagnet? A, a longer wire. B, fewer wire coils. C, an aluminum core. Or D, a large power source. Now, in order to answer these questions through demonstration, this is what I've come up with as far as experiments that we need to do. We'll change the number of coils, the number of batteries, that's the electrical supply or the power, and the material at the center, which is called the core, that we wrap the coils around. So we'll be doing 3 brief experiments. And as any good scientist would, yes, we have a data table. Data table has a title. The chart is the number of wire turns and how many paper clips are picked up. Please take note that there are 4 column headings. The headings tell you what information should be written underneath. Trials, we're going to do 3 because in a good science experiment, you do an experiment more than once. We're going to have 4 turns of wire around a nail, 8 turns, and 16 turns of wire. And in these spots, in these blanks in the table, we're going to write down how many paper clips we pick up. So, that being said, let's start to do our demonstration. Here's a battery. Remember, the point with the bump is the positive. The bottom is the negative. We have a nail, and we have a Yamongo piece of wire here. What I'm going to do is to take the wire and wrap it around 4 times. 1, 2, 3, 4. Now, I seem to remember I said I was going to pick up paper clips. Well, I've got those here. I'm going to put those out on the table. I'm going to take the battery, put the ends of the wire, one at the bottom, one at the top. That allows the electricity to flow through the wire. And let's move the nail now over top of the paper clips and see how many are picked up. I didn't see any picked up, so we would write a 0 on the data table for the first trial. On our second trial, Again, no paper clips were picked up. Let's do a third trial. None were picked up. That's our 3 trials for 4 turns. Let's go ahead and let's do 4 more turns. That gives us 8 turns of wire. Let's take a look at, with 8 turns, how many paper clips we pick up. That's 2. Second trial. 3. Third trial. 3. Now we're going to go to 16 turns. Making sure that the wire touches both ends of the battery. Let's do our first trial. Okay, we have 1, 2, 3, 4, 5, 6. Second trial. We have 4. Third trial. We have 1, 2, 3, 4, 5, 6. So, in doing this first activity, our variable, what we were changing in the experiment, was the number of turns of the wire around the nail. That is what we changed. The battery, we had 1 battery, and our number of paper clips remained the same. Let's take a look at our data. Our data table's been filled in with our results, and you see the area that's shaded here is called average. That's where we add up the numbers in the column and divide by the number of trials, which in this case was 3. So we have a 0 average in the first column, which was for 4 turns of wire. For the 8 turns of wire, we picked up 2, 3, and the third trial 3 paper clips for an average of 2.67. And for 16 turns of wire, we picked up 6 paper clips, 4 paper clips, and 6 again for an average of 5.53. Well, it's really nice. We have a data table, but what does the data show us? You need to think about that. It's very important. Let's take a look at the data table one last time. Are the numbers going up? Are the numbers going down? As we increase the number of turns of wire, that's right. Good. The number is going up. So we can say, based upon our data, what does the data tell us? It tells us the more turns of wire you have around the nail, the more paper clips it will pick up. First piece of information. Let's now take a look at changing the amount of power that we have on the battery. So let's move our pile of paper clips back into our nice area here. We're going to go with 20 turns of wire, so we're going to change the number of turns. So we're at 20 now. And just as we did with the first data table, we're going to try this 3 times and record our data. Here we go. We'll count that. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, 7. And our third and final trial. 1, 2, 3, only 4 that time. Okay. Now remember, we're not changing the number of turns of coil. That stays the same. Now, we're going to use 2 batteries. We're increasing the power supply. Let's try this now. Trial 1. Okay. We have 1, 2, 3, 4, 5, 6, 7, and I drop one to my lap. That's 8. Okay, we had 8 for the first trial. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on our second try. And our third try, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's 10. 10 again. All right, we're now going to use not 4, but 3 batteries. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, that's the first trial. Let's try this again with the 3 batteries. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, and for our third and final trial, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. Now remember, in this data table, we were doing what? We went from 1 battery to 2 batteries to 3 batteries. So we're changing the amount of force, or the amount of energy that's put into the electromagnet. Let's take a look at our data. Same idea as in the last data table. We have averages. With 1 battery, the average picked up was 5.67. With 2 batteries, the average was 9.33. And with 3 batteries, the average was 22. Again, we ask the question, what does the data tell us? In this case, as we increase the number of batteries, the number of paper clips picked up also increases. That's the second bit of information. For our final activity, we're going to change the material in the middle of the magnet, of the electromagnet. We're going to add a couple more turns to the wire. And now we're going to try 1 battery and see how many paper clips we can pick up, again doing 3 trials. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 for our first trial. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for the second trial. And our third trial, one, 2, 3, 4, 5, 6. So that was one battery using 24 turns and a nail. What we're going to do now is to take a pen. We're going to stretch out the wire and we're going to make 24 turns on the pen. Okay. Trial number 1. No paper clips. Trial number 2. No paper clips. Trial number 3. No paper clips. Okay, and now let's go from the pen to a pencil. Trial number 1. No paper clips. Trial number 2, no paper clips. Trial number 3, no paper clips. Now that's interesting. Same battery, same amount of turns, but we used a metal nail, a plastic pen, and a wooden pencil. Let's see what the data shows us. As we look at our trials and the averages, the nail had an average of 10.67. The pen and the pencil both had 0. So from this data, what can we say? We could say that the material that is in the center of the core does make a difference. Let's take a look at the two questions that we started with. Question number 1. An electromagnet is shown below. Now remember, electro, like electricity, and a magnet. It's an electrical magnet. The power comes from a battery, goes through the wire, through the coils, with the metal nail in the middle, and you get a magnet created with electricity. What change would decrease the strength of the electromagnet? Using an iron nail, metal nail, using an additional battery, using more wire coils around the nail, or using fewer wire coils around the nail? Well, if you remember our data, the correct answer would be D. Fewer wire coils around the nail. And finally, question 2. A doorbell contains a simple electromagnet. Which change would most likely increase the strength of the electromagnet? A, a longer wire. B, fewer wire coils. C, an aluminum core. Or D, a large power source. If you remember the 3 demonstrations we did, the correct answer would be D, a larger power source. Now, ladies and gentlemen, boys and girls, MSA is coming soon. The Science MSA is coming soon. Please remember, get plenty of rest the night before the test, eat a good breakfast, come to school, and above all, relax. You have the knowledge. It's in you. Just find it. Thank you.